class time. All right, so here's trigonometry. First thing, it says it right big on your booklet. Make sure your calculator is set to degrees, not gradients, or radians. You don't want any of those, okay? So most calculators at the top of your screen have a D or a DEG for degrees or something like that. That's what you want it to be set at. The best way to check if your calculator is set to the right settings is go sine of 30, let's say. If you have my calculator, if you have I call those backwards calculators. If you still have one of those, you have to type in 30 and then press sine. Okay, so I might have to help you out with that, but you should get 0.5. Okay, if it's set to, let's say I'd set mine to gradients, and I went sine of 30, you're not going to get 0.5, right? So it's very important. Mine is super hard to change the setting, but some of you, honestly, if it's just in your backpack, the button to change it is right here, so it changes all the time, so you need to watch out for that. Always check, okay? On the exam day, I will actually remind you. It's like, everybody, let's go check, make sure our calculator is set to degrees, all right? Okay, for trigonometry, we have two tools that will help us solve for every single triangle. The first one is called sine law, and the other one is called cosine law. And it turns out that that's all we need to solve every single triangle that is that we're provided with. And then, so ultimately, we want to be able to tackle the word problem, right? So I'm going to teach you at first just how to use them with minimal context. It's just a triangle. Here's a bunch of triangles with side lengths and angles. But ultimately, you want to be able to solve word problems. The province has said that for the most part, they will provide us with a diagram. So yay, right? But I will also prepare you for the unlikely event that they're not going to provide you with a diagram. So I will walk you through that as well. Okay. Some prior knowledge. Okay, so this is important just to review. So I hope you remember, and if you don't remember any of the things that I'm talking about, still write them down and you'll probably wrap your head around that later. Isosceles triangle, it's when a triangle has two sides that are the same. We tend to put them like this, but it doesn't have to be just those two. But at the same time, what we know as well is that the angles across from these two sides, that is, I think, what often is overlooked, is that the angles across those two sides are also the same. So it helps us a lot, okay? Two sides are equal. Two angles are equal. So I'm shortening it just for, you will see me do this. When we talk about sides being the same or angles being the same, we often use the word congruent. Congruent is a fancy way of saying they're the same. And this is the mathematical symbol for that. So if that throws you off, don't worry about it. We're going to be fine. So I'm kind of going to repeat a lot of things so you kind of get used to it. Equilateral triangle, I think we're all familiar with that one. Okay, that's when all three sides are the same. They measure the same length. And therefore, all three angles are going to be the same as well. Okay, so it's still the same idea that the side lengths being the same guarantees us that the angles across from them will be the same as well. So I'll say this. Three sides are congruent and three angles are congruent. Sorry, I'm shortening. That's the symbol for angles, right? What do they all measure? Anybody? Do you remember? 180 is all three of them. So if you split 180 in three, you get 60, right? There's actually 60. You're guaranteed. I feel like I'm going to mess this one up. So we'll leave it for later. It comes back. Okay. Right triangle. Guess what? That's the one you love, right? That's the one well, maybe you don't love it, but you're used to it, right? So as soon as you have 190-degree angle, it's considered a right triangle. It could be upside down, so don't get too used to. As soon as you have a 90, it's a right triangle. Okay, good. Sum of interior angles is always 180 degrees. So it doesn't matter what type of triangle, right? It could be like this, it could be like this, it could look like this. It doesn't matter. I'm going to put ABC on to label every single angle in these triangles. I know you're used to capital letters outside. That is also accurate. You can use capitals outside, lowercase inside if you'd like. But this is just to illustrate that A plus B plus C is always going to be 180 degrees. Supplementary angles. This is what it is. Two or more angles whose sum is 180 degrees. That's what supplementary angles are. And I'm also going to write down complementary. So halfway, there's a big space after supplementary, so kind of figure out about halfway, maybe a little lower than halfway in between. Complementary angles. Angles whose sum, anybody remember this one, is 90. To help me remember, it is right to complement someone. It is right to complement. So then you know supplementary is the 180. I don't know. So supplementary, this is what you're going to encounter quite often, okay? Watch this. You're going to have a straight line like this, and at any point there's going to be another line intersecting it. So let's say you have this there. So I want you to see, okay, there's this straight line there. We know that that is 180 degrees. From end to end, we know it's 180. Protractor, no, won't help you because they're not drawn to scale. Yeah, unfortunately. So if I were to tell you, hey, this one is 30 degrees, this angle, the smaller one here, the acute, you would have to say, wait a minute, I know that this straight line is 180, so this has to be 150. Okay? Go ahead. It doesn't matter, like I could give you a line like this. Imagine a line going in a slant like this, and at any point there's another line meeting it like this. And you're like, wait a minute, what's going on? There's this one straight line, and that straight line measures 180. So if I were to tell you that this is 70, What are you going to tell me about this one here? 110, right? I'm going to pause here for a bit just to clarify, because this does happen. Look at this. This is the point where lines meet, right? Right here. Sometimes students are like, is it this one here? No, right? There's no straight line there. So I almost want you to think this is a point and there's 3 sides coming out of it. Only 2 of the sides make a straight line. In this case, it's these 2. Same thing here. You make a point, that's where all these 3 segments meet. Only these 2 make a straight line. There's no way you can get it this way. Okay? So this is your straight line. That's the 180. So there we go. And one last example here. I find this one is it shows up on exam. So we're gonna make a triangle, but we're gonna extend the base a little bit here. This actually happened before, this part right here. This is what they did. They would have told you that this is 120 here. That angle is 120. The angle outside the triangle doesn't help us really to solve. But you should have realized, oh, wait a minute. There's that point again where, right, lines meet. Only these 2 segments here make a straight line. So if this is 120, then what is this going to be here? 60. Again, I want you to think of, right, a 180 like that. And maybe I should clarify, some students are thrown off by, I'm just going to use one of the previous triangles. Whether I do this, or this, or this, or this, it doesn't matter. The angle is always going to measure the same. So don't let that throw you off, like how big the curve is. It's just indicating that from this side here, measured to the other side here, it's a certain degree, right? That's all. Complementary. Similar idea, but here you're going to see something like this. You're going to see one side going this way and one going that way. Okay? And they're going to tell you there's a 90 there. And out of that corner, there's going to be another side coming out. So let's say I told you there's a side coming out like that, and I were to tell you that this is 50. What do you think this other chunk here is going to be? It's going to be 40. Because I'm told that these 2 sides make a 90. So if you have part of it, take it away from 90 to get the other part. That's it. Fun stuff. So that's complementary. And the dreaded 3-letter notation angle for angle notation. I don't want you to dread it ever. I want you to read it and put a letter there that you prefer. That's what I want you to do on a diagram, okay? So watch this. For angle notation, we have a 3-letter notation. For sides, we use 2 letters often, not always. But look at this. Triangle, ABC. We're going to give that letter, we're going to call that angle K. Angle CBD, I'm going to call that angle Z. CDE, angle X. Angle BDC, I'm going to call that angle Y. For side lengths, on this side, I'm just going to go number 1, 2, 3. This is just to identify where it is. So that's what I want you to do every time. If there's a 3-angle notation like that and it drives you nuts, it drives me crazy, to be honest. You're already crazy, Mr. Durson. You can't get crazier, can you? Anyways. This is what I do. I'm like, you know what? I'm going to go find it, and I'm going to put this letter in it, and then I can work with it and not have to worry about this anymore. So where's angle ABC? This is the symbol for angle, by the way. We go over there and just read it the way it's listed. A, B, C. So it's, if you were to connect these stretches here, it's talking about this angle right there. That's angle K. So put a K here. Can you find the other three? See if you can do that. I'll just pause for a second, update my attendance, and then we'll be back. Guys, right? Even if you're not sure, try it. Put it somewhere. Angle CBD, right? So you go CBD. So it's connecting. You gotta forget about everything else. It's almost like if I were to connect this, if I were to draw that segment, that angle here is what it's referred to as Z. Okay. CDE. So you draw this, and one's this one. That's X. BDC, it's asking for this one here, Y. If there's only one angle here, right, you could just call that angle C. But technically we cannot just say angle D because if we've got this one and this one in the mix, right? So we got to specify. That's when three-letter notation is often used to narrow it down. Line BC would simply be from here to here. That stretch would be called BC. DB is down here. That's 2. And DC is 3, right? So these are the side lengths that we're talking about. So side lengths, and then angle is that one. Okay, so hopefully that was a good review for you. Let's keep going. I know you're tired, and my voice is probably telling your brain, go to sleep, go to sleep. All right, labeling. Page 3. So just another reminder of how to label. We use capital letters for angles and lowercase letters for the sides across the angle. So example, if I ask you to sketch triangle XYZ, okay, that is triangle, okay? So you're supposed to draw a triangle. Don't draw a right triangle because chances are in this unit, yes, you're going to get a few, but chances are they're not. So draw it like this. I always make a roof. Like this is one side of the roof, and the other side is a little longer. And if I mess up, I just erase the whatever's there, right? So X, Y, Z, it doesn't matter where you start. You can start here, here. It doesn't matter. Unless I specify that, like if I were to tell you XZ is at the bottom, is the base, other than that, it doesn't matter. So X, Y, Z, and then therefore, this would be lowercase y across from angle Y. Z would be lowercase z here. X would be lowercase x there. Okay? So you've got that triangle there. I don't know if you want to do that, but labeling usually we go across. We have pairs across from each other. Okay? Angle of elevation and depression. All of this you should have seen before. This is my best way to explain stickman, right? So you've got your line, your horizontal line is the line of sight. So I'm going to use a ruler. If you don't have one, no big deal. Try your best. So there's always a horizontal, always. Sometimes it's the ground. Sometimes it's actually up the surface of the ocean. It doesn't matter. There's always going to be a horizontal. So that's going to be my starting point. I'm going to actually highlight that one. And nowadays, the geese are migrating or getting ready, right? So if you were to see a bird up here, or you look at the top of a tower, of mountain, or building, that's going to be that's going to create an angle of elevation. I think I messed up. I don't like where the horizontal is. Is that gonna throw off your notes? If you don't want to erase it, just make it work. But I should have thought ahead. I want to write in here. I'm gonna write horizontal out here. My bad. Some of you are gonna hate me right now. Messed up my notes. Okay. Anyways, this is the angle of elevation. Right now, I would like to add an arrow because I actually want you to think of, you're always going to start measuring from the horizontal and then you go up until you hit that line of sight, in this case going up. If you see a bug, or if you were to look at the ground, okay, it's a tick, right? You're gonna tilt your head down and look at that object, or in this case, bug, right? In this case, we would measure from the horizontal down, right? And that would be called the angle of depression. Okay, depression. So just so we're clear. And I'm going to give you small little diagrams, right? Example, the angle of elevation to the top of the tree is 40 degrees, let's say. If I were to tell you that, okay, you immediately would be like, okay, this is the tree, okay, and there, in this case, the horizontal is my ground. So from wherever you're standing, it's going from here to the top. So I would expect you to know that the 40 goes in there. That one is, to be honest, this one, students don't struggle with angle of elevation as much. They do struggle with angle of depression. Okay, so example, pilot sees the airport at an angle of depression, that's what AOD stands for, of 25 degrees, let's say. So the idea is here, a pilot is flying and looks down. Obviously, it would have to be an angle of depression. So imagine the plane is up here. I'm showing my weaknesses by, looks like a bird turning into an airplane. Anyways, and this is the airport right here for us. And this is where students struggle to see the horizontal line. Because it's the ground, Mr. Dirksen, right? No, in this case, where is it measured from? It's measured up high, right? From up high there somewhere. So you're going to go to your plane, and you got to have an imaginary horizontal line in this case. It's not the actual ground. Okay? And then you're going to be like, okay, now the pilot is looking down at the airport. And this is the 25-degree angle. And I'll give you the most common mistake. You ready for this one? Students want to, for some reason, they want to say this is 25. And that's wrong. Okay? This is not, if you did it this way, is there horizontal at all? No. There's a horizontal there, right? There's a horizontal. So I will use the same green that I used for the original and just say, hey, here's your horizontal. You have to make that one up. Here's your horizontal. It was actually the ground in that story. So keep that in mind when you're working with these. We're almost ready to start the actual unit. It's all review. I hope. Do you remember some of these things? Yeah. Some of you are like, sort of. Well, that's good. I don't expect you to remember everything because it's been a while. So keywords. Honestly, these are just important things to remember. Your compass rose. Some of you are just good at remembering this, but some of you might have to put this on your study sheet. So north and south, we don't really struggle with. Okay, but west, east, that's where some of us struggle. And you have your teachers taught you clever ways of remembering, I'm sure, in elementary. But I just want to make sure that it says we, not you. Like if you read it from left to right, then you know, okay? Keep that in mind. I'm just going to keep that there. And another one, last one. If speed and time is provided, comma, then distance, I'll say distance traveled. This one you might want to add to your study sheet is speed times time. If you're taking physics, you probably know this one already. Example, you're going 80 kilometers an hour over a period of 2.5 hours. How far did you travel? Distance. What's my speed here? 80 kilometers an hour, right? We're going to multiply that by 2.5. 200? In this case, 200 kilometers. It could be miles. But this is going to be important when you have a scenario where a boat leaves the dock and travels at 30 kilometers an hour for 3 hours, then turns. Right? So you will be able to figure out the distance or the side length of your triangle by doing this. Okay? More about that later. We're not going to spend too much time on this, but you can't say that I didn't prepare you for that. Okay? So that's the intro. That's warm up.